All right. Hello, everyone. Good morning and good afternoon. Welcome to the ASA section on Statistical Learning and Data Science monthly webinar. My name is Boxiang Wang from the University of Iowa, and I will be your moderator. Before we begin, I would like to briefly promote two upcoming events. The first one is a conference called STIC, which will be in July at Harvard, and this is our first peer-reviewed conference. The second is our SLDS session conference in November in New York City. We warmly welcome you to attend those meetings. Now it's my great pleasure to introduce today's speaker, Dr. Hadley Wickham. Hadley Wickham is Chief Scientist at POSIT PBC, winner of the 2019 COPS Award, and a member of the R Foundation. He builds tools, both computational and cognitive, to make data science easier, faster, and more fun. His work includes packages for data science, like the Tidyverse, which includes ggplot2, dplyr, and tidyr, and principled software development, like roxygen2, tested, and packaged-down. He is also a writer, educator, and speaker promoting the use of R for data science. Today's talk is on why code one AI. So let's figure out why. Dr. Wickham, over to you.
Thank you. Thanks for having me. So today I wanted to kind of share like my thinking about AI. I'm someone who writes a lot of code. Um, and it's really, I think, changed the way that I produce R packages, but I still fundamentally believe that code is super important. So that's something we'll talk through today. And given the success of packages like Gen Z Plyer, I also have an alternative talk title for you, which is genuinely skills maxing for real before you get code mogged by AI. So if you understand what that means, you are well set up to succeed in the coming years. So I want to start with kind of the big picture. And the first thing is, like, no matter how you feel about AI, like the genie is out of the bottle and it's not going back in. Like, I still feel like pretty ambivalent about AI, pretty conflicted. Obviously can be a tremendous lever in writing better code, but also, so many negative things, from the environmental impact to, it seems like it's increasing the concentration of wealth. It's all built on the theft of intellectual property on an unprecedented industrial scale. So, lots and lots of bad things about AI. And, I still feel like conflicted about my use of it, but it also feels like something that, like, we all have to deal with. It's coming, like it or not. We can't put the genie back on the bottle. But on the plus side, like, I think you can actually have like a great time with AI. Like, it can be genuinely fun and genuinely empowering. And for me personally, a lot of this sort of resolves around, like, changing the way that I think about producing code. Like, no longer is it me typing code directly into the computer, but now having this conversation with this robot, Claude in my case, which we'll come back to later, that, is interpreting my thoughts and, providing a pretty remarkable iterative feedback loop that I find, still find really rewarding. But there definitely is this kind of like fork in the road, that there's these two paths that you can take when using AI to write code. And the first one is the one you probably hear the most about in the media. And this is kind of the scenario where you become this like manager of an army of robots, this factory of robots who are just constantly beavering away day in, day out. And you're just trying to frantically feed them with as many good ideas as you possibly can. And this taken to its extreme leads to something like pretty dystopian. I don't know if any of you have seen Steve Yeage's. He's a pretty famous computer programmer, software engineer. It's Gas Town, but it leads to this pretty dystopian future where really all you're doing is trying to optimize like the sheer volume of code that you produce. But that's not the only way forward. I think there's also a way forward where you use AI to write higher quality code. And I think one of the things that's really interesting as we learn more about using AI for high quality software engineering is that just how many of the existing best practices, things like good documentation and strong tests and caring about how your code is organized, all of those things continue to be really, really important. And in many ways, like more accessible than they used to. Like if as the cost of writing code goes down, you can spend more time or spend more of Claude's time like architecting your code so it's easier to understand and easier to modify in the future. And I think the thing that's really important to hold to is that regardless of how the code is produced, it's still your work. You are responsible for the work that you and AI do together. And if you choose to not engage with that work, you can like churn out mediocre work faster than you ever could before with very, very little intellectual engagement. But that's not the only option. If you really dig in, I truly believe that you can produce like higher quality work than you ever had before. Because at the end of the day, I think the best metaphor for AI is as an amplifier. Like if you want to be lazy, like you can be more lazy with less effort than you ever have at any time in the rest of human history. You can solve problems with basically zero intellectual engagement. But that's you don't have to do that because it can also amplify like the best of us. Like you can use it to go deeper, to engage more in any of the domains that you're working in. And I love the quote from Tukey about how statisticians get to play in everyone's backyard. And AI gives us that ability to do so even further and to go even deeper than we have before. And I think to me, like that's one of the reasons that I think like statisticians and data scientists are well posed, are well set up to do well in this era of AI. That we have the skills to program. These skills are now massively amplified. If you know how to program in one language, you can now effectively program in any language. This deep ingrained skepticism about like where is data coming from, like who collected it, why did they collect it, what are the things we need to worry about here, and this understanding of variation, which I think is so important with LLMs, since that they are like fundamentally stochastic machines. So LLMs, AI, I think a massive amplifier. Certainly you can use them to amplify the worst aspects of yourself, but you can also use them to amplify the best aspects. So now I want to kind of go turn my sights on something a little bit more practical, and just to make sure, just to level set, because there's so much variation in what people understand about AI, about LLMs. The best practices are changing at a pretty frantic rate. So, if you're basing your opinions on AI of like as of 6 months ago or a year ago, like that's sadly outdated. So I want to give you some concrete advice about the things that me and my team and the folks that I talk to find most impactful. And the first is just to be clear that there are like three companies producing these so-called frontier models, the kind of the best of the best. And the first, and my personal favorite, is Anthropic, who produces Claude. Uh, tends to be a little bit more expensive than the other models, but in my opinion, it's the best all-rounder. It's certainly the model that I find best at writing R code. This is what produces probably 90% of the R code that I write today. Not always that great, but surprisingly insightful and knowledgeable. It's sometimes surprisingly dumb at other times, but we'll kind of come back to that briefly and how you come back to that later and talk about how you protect yourself from that kind of dumbness. Then, of course, we've got ChatGPT produced by OpenAI. I hear a lot of positive things from my colleagues, particularly for using it for code review. I think the downside of ChatGPT is it has the most obviously evil CEO, which is not to say or any of these CEOs are like uh, unanimously good, uniformly good, but Sam Altman seems to be particularly obviously evil, in my opinion. And then finally, you've got Gemini by Google. I think this is kind of a bit of a distant third place. The advantage is that Google desperately wants to stay relevant and has huge buckets of money to spend. So if you're trying to save money, Gemini seems to be pretty aggressively subsidized. It's got a pretty good free plan. You can get a lot done with Gemini without spending much money. And at the end of the day, it's not much worse than OpenAI and Anthropic. It's also really good at image generation. That's what I use to produce all of the images and the slides I showed earlier. And of course, because I'm me, that is now all automated in an R package called Bananarama, which I use to generate the majority of my slides. Okay, so those are the frontier models, the best, most expensive to create and to consume. On the other hand, you've got open models. So open models, sometimes also known as local models, because these are models that you can actually download and run on your own computer. A lot of promise here. They seem to be roughly trailing behind the frontier models by kind of 6 to 9 months. So if a frontier model can do it today, then in a year's time you can be reasonably certain that one of these open models is going to be almost as good. And that kind of implies there's this really big inflection point in the use of AI for coding that happened around the end of December last year. That's when like Claude Code and Codex really took off. That's when there was some kind of step change in their functionality that really has dramatically transformed the practice of software engineering. So based on that prediction, we should be expecting to see open models, getting good, around about now to the end of the year. And I think we're starting to see that. So Gemma 4 from Google and Queen 3.5 from Alibaba are showing a lot of promise there. My colleague Simon has written a blog post about this recently, showing that these local agents are getting pretty good. Now, I think it's better to focus on these being open rather than being local, because if you want to run them locally, you still need like a pretty beefy computer. If you have got like a really expensive MacBook, those are pretty good. Otherwise, you're going to need specialized GPU hardware, which is exceedingly expensive at the moment. But even if you're running an open model like on someone else's computer, there's a lot of competition there to drive prices down. So if you want to use one of these open models hosted somewhere else, those tend to be pretty good deals. But the most important thing I want to tell you is that if your primary way of using an LLM is through a chatbot interface on the web or your phone, you are missing out on like 90% of the goodness, at least. Like chatbots on the web, are great for your kind of casual exploration, the questions that come up in your personal life. I use them all the time to create recipes, to use up leftovers in the fridge, to answer questions I have about gardening and things in Texas and just random facts that I want to learn more about. Really fantastic. But if you're using them for data science, for programming, you're missing out of 90% of the business. So what should you be using instead or as well? And I think there's like really two paths here. The first is to write code that use LLMs. So that's like using a package like my Alma package, which lets you talk to LLMs from R. And it's also using LLMs to write and run code, giving them an environment where they can write the code, run the code, look at the output, and then iterate, which, as I'll talk about shortly, is super, super important. And I think like if you're a data scientist, you should learn to program with LLMs because they give you data science superpowers. In particular, there's this toolkit called structured data extraction, which makes it very easy to go from unstructured data, whether that's text or images or PDFs or video or audio, whatever, to go from that unstructured data and get it into a nice, tidy rectangle. And once you've got that rectangle, you know, all of your existing statistical and data science skills can come into play. So this is just a very small snippet of what that looks like in Alma. I'm first going to define what I'm trying to extract. I'm going to try and extract something with names that are strings and ages that are integers. And then I can give it some data and it'll extract from free text, from unstructured text, the name and the age. But the thing that's like really cool about this is you can very similarly do exactly the same thing now with images. So I kind of made these little note cards. Previously, this is a task that would have required a ton of specialized machine learning. Now you can throw this into, you know, about bog standard LLM and extract that data into a data frame. Now you can use this, you know, in any way you already know how to use data. So super, super powerful, opens up, you know, really wide areas of analysis that were previously inaccessible to the data scientists. Yeah, so that I think of as like writing code that calls LLM. So here we're going to write code, we're going to write a function that basically works like any other function in your programming language, except behind the scenes, it's using an LLM, which means we can give it vague tasks that we haven't precisely scoped out like we normally need to do with coding. The other approach is to run the LLM in an environment where it can write the code and run the code and inspect the outputs. And this, I mean, I think this is, you know, when you think about this, this is eminently reasonable. Like if you give a human the task to like sit down with pen and paper and write some R code or some Python code, you've got to be like a pretty darn good programmer before your chances of like writing code that actually runs, let alone gives you the right answer, is reliable. So, you know, as a human, what do? Like you take a stab at it, you try it out, you look at what happens, and then you churn the crank to get better and better. And so this is all about giving LLMs that same opportunity, giving them a harness so that they can run code and get the outputs. And there's two ways you can do this inside of Positron or RStudio. One is to use Posit Assistant. Posit Assistant is Posit's AI assistant. You can use it with any LLM provider, or you can just run whatever you're currently using inside the term. Both of these have kind of pros and cons. The main advantage of Posit Assistant is you have like an R environment, an R session or a Python session that both you and the AI are collaborating on. That is so useful because when the AI writes plotting code, now you can see the plot. When it writes data manipulation code, you can use the data view and actually look at that data. So I think this is like a super, super powerful. And it gives you this feedback. So yeah, so why do this? So the first thing is, well, just getting rid of copy and paste. Like if you are writing some code or asking ChatGPT to write some code, copying that from ChatGPT into RStudio, pasting it in RStudio, running it, then it doesn't work, and you copy the error message, you paste that back into ChatGPT, and it does something. What you have done is given the LLM like the fun part, which is like writing code and like thinking about code, and you are doing the boring, tedious part of like copying and pasting code back and forth between systems. And I think one thing we need to all be aware of as we think about AI impacting our jobs is like, how do we make sure we keep the fun stuff for us, for the humans, and we give the AI the stuff that is less interesting, is less fun. Also, I think the lesson we've learned from reproducible research from R Markdown from Quarto is that when you can do everything in one system, you're no longer copying and pasting between things. That's just more reliable, more robust, better science in general. Now, but also because the LLM can now run code, it can run code to be like, well, what packages do you have installed? What packages do you have loaded? And that means it's more likely to write the type of code that you want off the bat because it knows the packages that you're currently using. And it knows what data you have currently loaded. No longer do you have to provide that additional context. So the chatbot, like it can just derive it from your environment. It just knows you've got this data frame with these variables of these types and this is the column. So now your chances of getting high quality code on the first iteration are much higher. LLMs can also read your plots, and I have kind of an asterisk here. And I guess I forgot to share my Safari, so give me 1 second so I can share this with you. Safari. So my colleague Simon put this benchmark together. It's basically some plots. We just flipped one of the axes. So this is a plot of fuel economy. We've got the size of the engine on the x-axis and how many miles per gallon on the y-axis. And, like as a human, if you look at this, you're going to be like, that is pretty surprising. Like I would not expect the fuel economy to increase as the size of the engine gets bigger. But what an LLM does is often because it's pretty lazy, is it's just going to like look at the axis labels and be like, well, okay, fuel economy decreases as engine size increases. So if you give this to a bunch of models, like 80% of the time, it's going to incorrectly interpret this plot. So while LLMs can read plots, I think we're just in the early days of like understanding like what are the problems that LLMs have interpreting plots. And certainly one of those problems is just being lazy and just relying on what they really expect to see, not actually looking deeply. Obviously, a problem that we humans can be prey to as well, but definitely something you need to be aware of when working with LLMs. But most importantly, and I've said this several times already, it gives LLMs this feedback loop that they can write some code, try it out, and see what happens. And this is incredibly powerful. Like this, I think this is one of the things that took Claude Code from being kind of like an interesting novelty to something that like every software engineer basically demands to use today. Because it's not that LLMs are like necessarily always that smart. Sometimes they show these like pretty astonishing flashes of insight and intelligence. And other times they are just like crushingly stupid. But when you give them a feedback loop, even when they're being dumb, they will just grind their way doing stupid thing after stupid thing after stupid thing. If they have this feedback loop, they will eventually often just grind their way to an answer in a very, very slow and painful way. But at least it's them doing it. It doesn't involve you as a human. And this feedback loop is like, really, really painful, like really, really powerful, because this is the kind of the feedback loop that you start with, when you start programming, you write some code, you run it, you get some error message you don't really read, and you just randomly make some changes. And even this not very good feedback loop, like eventually gets you to success. LLMs have this even more powerful feedback loop because one of the things LLMs are better at than humans is they will actually read error messages. And this is a surprisingly useful skill because error messages are not always informative, but they are often informative. And so reading an error message can lead the LLM to produce code that's more likely to be correct. Or they can read documentation because in R and Python, just reading documentation, like generating documentation, that's just another function. So now they have this ability to introspect, like what can functions do? They can read examples, they can look up edge cases. Just super, super powerful. And this is like super useful for, particularly useful for package development or software engineering because we have this notion of unit tests. And unit tests are kind of like the double entry bookkeeping of software development. They allow you to say, like, what do I expect this function to return? And I think this is the number one, this is the biggest difference between software engineering and data science. And one reason that AI is being adopted a little bit slower in data science is that when you're a software engineer, you typically know what you expect to see. Like you have some vision in your head of like what this function is going to do, what this code is going to reveal. But very often when you're doing data science, you're doing it because you genuinely do not know the answer. That is why you're doing data science. That is why you're doing statistics. You're trying to answer a question that maybe no one has answered before. And so that means like in data science, we don't have this feedback loop. I'll very, very shortly like talk about maybe what we have, some speculation about maybe what we have instead. But this driver, this ability, even when the LLM is both writing the tests and writing the code, just because you've got that double checking, like the chances of both the code being wrong and the test being wrong in exactly the same way is much, much smaller than either of them being wrong independently. So this cycle of testing and running code, this is just a really powerful engine to drive software development. But that's different to data science, as I've said. In data science, we don't have this. We don't know what the right answer is. So what is our feedback loop? And I don't know. I don't know. Is there one? Is it possible to automate? I think it's certainly many parts of our jobs that we're going to be able to automate. Hopefully the parts of our jobs that we like the least. But there's no way to like write a unit test to say like, is this plot informative or is this the correct model? So kind of fortunately for us in data science, I think there's still an area, there's still a big role for humans. And so that tends to mean like when you're doing data analysis, assisted by an AI, the AI is going to have to be checking with you much, much more frequently than when it's doing software. But there's a few kind of experiments that I've been doing because I think there's this kind of meta technique, which is like this question of like if LLMs are writing more and more of our code, how do we reassure ourselves that the code it's writing is correct? And I think one way we can do this is by asking to express itself in a variety of different ways. And if all of those ways kind of line up and tell us what we're hoping to see, then that we feel more trusting of the model than if we're just looking at a single output. The one way I've been exploring this idea is through the idea of data dictionaries. So data dictionaries, obviously something that have existed for a very long time, but it seems like they're particularly important today because there's a lot of knowledge that you have about the data set that your AI agents do not. And you need some way to convey it to those AI agents. You need some way to like write that down in kind of a semi-structured format, which we'll see shortly, so that your AI agents can use it. And I think the kind of funny or possibly depressing aspect of this is this has always been true, right? It's always helped your human colleagues if you write down what you know about a data set, but somehow it is way more compelling to do this for an AI agent than it is for your human colleagues. So let's take a look at a data dictionary, which I have opened up in Positron here. This is a data set about elevators. Elevators in New York City. This is a data set that came to me from my colleague Emil Pitbelt. And this is its data dictionary. So what is a data dictionary? Well, we've got a list of tables. This data set just had one table in it. It's data about elevators. We've got some free text telling us about this. This is registered elevator devices. You might already be wondering, well, what's the difference between an elevator and an elevator device? You might use some answers of that later. Where did this data come from? The New York City Department of Buildings. How did we get it? It was a Freedom of Information request. When did we get it? September 2015, so probably a little out of date now. What have we got? About 76,000 devices. Okay, so what are those devices? We've got elevators, escalators, dumbwaiters, and other vertical transportation devices. So we're getting some context for this data. And where is this data? Well, it lives in a Parquet file. If you do not know about Parquet files, I highly recommend learning about Parquet files. If there's one word that you remember from this webinar, it should be Parquet, because Parquet files are like CSV files, but like basically better in every possible way. They are much smaller, they're much faster to work with, and they encode information about the types of each variable and missing values in a way that is robust from session to session, and you can easily share this with your colleagues no matter what other programming language that they use. So that's with the data, and now we're going to describe each of the columns in this data set. So I'm not going to go through these exhaustively, but for each column, we've got the name. Okay, this is the DV device number. We've got what sort of type it is. It's a string. We've got any constraints we know about this. Okay, this column's the primary key. It's a unique identifier for each elevator device. And again, we've got some free text, and then we've got a few examples. So seeing examples, so useful for humans and for AI agents. In this case, just with 5 examples, you probably look at this and say, well, it looks like there's some structure in this identifier. They all seem to have some number followed by a letter, followed by another number. So maybe this is some kind of composite key that's actually made up of other things. You know, something you probably want to dig into if you're doing more of this data set. What else do we have? Well, we've got the status, which is an enum. That just means it comes from a fixed set of possible values. Yeah, A, D, H, J, or W. It's required. It's a single letter code with registration status. Okay. So, and then hence, and so on and so forth for every column in this data set. We can see what sort of data it is. We've got a place to jot down what we know about the data, and we have some examples that help us see the type of typical value. So we've got lots of columns. In this case, we've only got one data set. If you've got multiple data sets in a data dictionary, you also describe the relationships between them. But here we also have a glossary. Glossary is super useful because there's always going to be domain or data-specific terminology that you want to describe to your colleagues, to the AI agent. Like a great one here, I think, is DOB, which you might automatically assume means date of birth. In this context, it means the New York City Department of Buildings. So really nice to have that domain-specific glossary at your fingertips too. Okay, so this is kind of the static data dictionary. But I think one of the big values to me of this data dictionary is the dynamic component of it. And so I'm going to show you some Git diffs. if this loads. So, okay. Why is this not working? Okay, here we go. Okay, so here I have a git diff, where what I did was consistently represent missing values. So, and I can see this in kind of three ways. So the first way is I can see what code did the LLM write? Well, it wrote something that loops over all of the columns and replaces any empty strings with missing values. And then it also modifies the zip code column so that any entries with 0 now get a missing value instead. So now we've nicely and correctly encoded our missing values so that they are no longer in inconsistent ways. And we can also see that in the data dictionary because it's removed this comment saying some values are 0, indicating missing data. The great thing about conventions and the great thing about having specific ways of representing missing values is you no longer need to write that knowledge down. It's implicit in the data. Or what else did we do? I did this. This is another one. So in this change, I parsed the dates. So before this change, you can see all the date columns were just listed as strings using YYYY MMDD format. After this, Claude has written some code to transform these character columns into date columns. Now we've got proper dates. Now when we plot those or compute means or other summary statistics, we're going to get correct summaries rather than working with strings. And again, we can kind of reassure ourselves that the Claude has done the correct job because we see both the change in the code and the change in the data dictionary. Now, the one thing that's missing here and the one disadvantage of Parquet files compared to CSV files is there is currently no way to look at a diff of a Parquet file. So this is something that I think that feels really important to me because when AI is writing code, you want to be able to see exactly what it did to your data. So this is something I'm hoping that we can implement in the future. So as well as the changes to the code, as well as to the changes to the data dictionary, you'll be able to also just scroll through and look, well, exactly what changed in the data. So I think this is a really interesting and powerful pattern that by representing what the LLM has done in a variety of ways, it's easier for us to reassure ourselves it's done the correct thing rather than just looking at a single representation. And this is basically just what I showed you. When you're doing data cleaning, you've now got this workflow where you ask Claude to, parse the dates or fix the missing values. And you can see exactly what it's done. It's representation of the R script, the Parquet file, and the data dictionary. Another tool that we've been working on recently is ggSQL. And, if you've heard of ggplot and you've heard of SQL, you can pretty easily imagine what ggSQL is. This is just ggplot2 syntax expressed as SQL. So, if you're familiar with R, Python, you're probably like, well, why would I want to do that? And that is a totally reasonable position, but there's a very, very large number of people who only know SQL and don't know R or Python, and those people have not had a good visualization framework before. So now you can write SQL code that gets visualizations in the same way you can write ggplot2 code or plot in R or plot9 code in Python to create visualizations. And again, this is powerful because now you're helping people move away from a point and click GUI to text. That text is great because an AI can write it for you, and you can diff it to see what's changed, and other people can read and critique it. And so this is the type of plot that ggSQL produces, which unsurprisingly looks pretty similar to what you might see from R or Python. And so I think there's sort of two other aspects of why, what has this got to do with AI? So the first thing it's got to do with AI is if you're asking your LLM to generate code to create plots, if you're doing that with R or Python, it has to be able to run R or Python code, and R or Python code can do anything. And in many scenarios, that's fine. Like if you're just exploring locally on your computer, you're not going to ask it to do anything crazy. And it's probably you're not going to try and deliberately do prompt engineering to make it delete all the files on your computer, but it certainly has that power at its fingertips. And so one of the advantages of ggSQL is it's just SQL. So an LLM can generate this, and we can visualize it, and you can know you don't have to run arbitrary code. The other kind of less obvious thing that AI has to do with this is this is a project that we could have done anytime in the last 5-10 years. But we didn't because it would have been a lot of work. It would have been probably a year's worth of work to get to the point where we could say, do people care about this? Now with AI, we can do this sort of experiment so much more quickly that we can produce a tool that other people can use who are not familiar with R or Python. We can do that in 3 months now instead of a year and get feedback and iterate. And certainly the response to ggSQL has been great so far. And it's something that we will continue to invest in. And the only other point I didn't mention, the other thing that's kind of cool is if you just ask an LLM to pretend that ggSQL exists and write SQL code to create a ggplot2 visualization, it's not actually that far away from ggSQL. So obviously with ggSQL, we give you a prompt you can use to get the AI to produce high quality plots off the base. Ideally you want to give it this feedback loop so it can try. ggSQL gives an informative error message, and if it's not perfect the first try, it can try again. But does an amazingly good job with very little prompting, because we've kind of deliberately designed ggSQL to be this sort of mind melding of ggplot2 syntax and SQL syntax. Okay, so to sum up, I kind of given you this big picture view. The genie's out of the bottle and we can't stuff it back in. But it's not all bad news, because at least for me, working with AI can be tremendously empowering and fun at times. And a lot of this just centers around changing what it means for me to be a software developer, to be a data scientist, to introduce this new collaborator Claude that's helping me write a lot of code. But still, you absolutely get out what you put in. Still more important than ever to sweat the details, to go deep, to stay intellectually engaged. And, I believe you can use that to produce, the best work of your career. But really important to bear in mind that you have this choice between quality and quantity. And this is not, it's not an either or. There are definitely times where you just need to quickly prototype something. For one thing that I use Claude for, that's where I just don't really care about the quality of the code, is just to whip up a quick Shiny app. It's basically free to create a Shiny app now. You can create a Shiny app to answer one tiny question in a data analysis. I did this the other day. I was doing a clustering analysis, and I was kind of manually taking, well, how does it look if I do 4 clusters? How does it look if I do 8 clusters? And I was I should just make a Shiny app. Claude can do that, can give me a slider. I can just drag that back and forth, look at the output. I don't really care about that Shiny app. The quality is unimportant. That's a great place where velocity or quantity is more important. But for the stuff that you really care about, that's important to you and your professional development, you can go deep on quality. You can use AI to like pick apart your ideas, to pick apart your code and produce higher quality work than you did before. Because at the end of the day, AI is an amplifier. And I really urge you, the best of your abilities, to use it to amplify like the best parts of you, the most human parts of you, not the laziest parts. Thank you.
Okay, thank you very much, Dr. Wickham, for this excellent talk. Now let's stop recording and we will open the floor for questions. Do that.